Okay, I'm here to talk about what we've done to GDI. That's what we call our graphics component and our graphics group. So again, like user is the name of the group, GDI is the name of the group. Again, this talk, like Scott's, was meant to be given to people who were very familiar with Windows, and so it really talks about differences between the new and the old. So if you need more details, ask, and I'm willing to fill in any details on what the old stuff was as well. Okay. This first slide concerns general changes across all of the interface, and they're very similar to what Scott talked about. Of course, our coordinates will be going to 32 bits, handles will be going to 32 bits, and counts and sizes can now be 32 bits, so we are getting rid of all the segment limitations that we had with DOS. Functions return error indications, Scott covered that. Objects belong to one process. Okay, this is more of the security thing. So you can't create DCs and bitmaps in one application and expect that their handles are visible to others. Everybody's in a separate handle space as well as address space. Okay, these are some very specific changes, not particularly relevant. General here. So automatic brush origin tracking. This is a problem we had in Windows, and we're just fixing the behavior, so that's very relevant to this discussion. Applications don't load device drivers. That concerns security and client-server separation and all that. Since we're going to have a client-server separation, applications shouldn't be able to even see the device drivers. Someday they may be on different machines, so you have to keep those separated. Pack points and escapes, those are very specific changes to people writing Windows code. A big one that brings up a good topic is PELs may change from Win16. That is, the PELs that we're going to display on the screen may be a little different. And that's because, for the most part, our curves are changing under Windows. We had only ellipses that were oriented vertically and horizontally properly. And now we have general curves of many natures, and so we're changing our fundamental representation to Béziers, and of course, if you take an ellipse, crack it into 4 Béziers, the PELs are going to be a little bit different. Okay, that's the majority of the changes. Some PELs may also change just in line drawing, but this has to do with the fact that we're now keeping a fractional representation of the endpoints of the lines rather than just rounding everything to integer coordinates. We figure that the change shouldn't be much bigger than going to a different display device, going to something with a different aspect ratio. PELs would also. So, at some point, if you want to talk about exactly what PELs we do draw, I'm willing to talk about that. We have a very specific imaging model now, and under Windows it was never really publicized what we did. Okay, new GDI features. So all the rest of these things are new things that we're adding. The first is that not only bitmaps, but all surfaces are considered to contain palettes. That is, any device you talk to has a color palette that it can represent. Okay, and we're also allowing that to be set with bitmaps. That is, when you say, I have a bitmap that I've stored on my disk, it comes in with a color palette. It tells you how to translate the indices in the bitmap into what real colors you're interested in.
So what happens when you render that palette into what happens when you render that palette into a window? It has already a full color map.
Okay, I believe the question is what happens when I split the bitmap into a window. Okay, I'm going between two surfaces. The bitmap's a surface, the device is a surface. I'm going between two surfaces with different palettes. I'll do translation and try to get the closest color match that I can.
I see. So for every color that's in that palette, we'll just try what kind of algorithm to use for color matching.
Well, okay. The algorithm we'll use. We
Actually,
attempt to be fast.
Tomorrow.
So what's that?
Let's talk about tomorrow.
Okay. No, fine. Yeah, but we try to do something fast, and we try to pre-calculate and cache all these things. Okay. So, and you're allowed, of course, on many devices to set your color palette, and we expect that's what people really do when they have these nice color bitmaps. Set the palette, and then it's an easy translation. Okay. Brushes used to be limited to 8 pixels by 8 pixels. That isn't very useful on very high resolution devices. So now they can be any arbitrary size, choosable by the device, generally for the stock patterns. Lines and text, under Windows, they can only be solid colors. Now you can choose arbitrary brushes, get patterns, dithers, gray levels, whatever is interesting into lines and text. And again, that's a high resolution device thing. It's required these days. As I already mentioned, all of our curves will be based on Beziers. Absolutely everything is broken down into Beziers, and then depending upon the device, could be broken down further into lines and then sent out. We're adding paths to the system. These paths are used by applications in the form of, the application issues a begin path call, then a bunch of drawing orders, then an end path. At that point, a path exists for this particular drawing context, and that path can be used for stroking, filling, clipping, etc.
Can you get a region from a path?
You can get a region from a path. Yes.
Can you get the path that corresponds to the outline of the text character?
Yes. You do that by saying begin path, do some text out into the path, and just draw some text into the path, and then say end path, and then you can read it back if you like. So you can do all kinds of really neat special effects. Get your characters back in terms of Bezier outlines, map them onto spheres or anything. But that's really up to the app. We're extending the transform capability. Windows only could do only scaling. It would have what we call the window viewport. You'd have some window in your logical space, some rectangle that you'd specify, and then you'd specify some viewport on your device, and appropriate scaling and translation would take place to map between them. But that was pretty limited. We're going to allow arbitrary linear two-dimensional transforms. So you can do rotation, shearing, etc. Okay. This is going to be added as one extra layer of transform that precedes the old transforms. And its default is going to be the identity, so that old apps won't notice this change, but new apps can have fun with it. There are a lot of things that get derived from adding new transforms. First off, it will be good if we can take our metafile and play them back through these arbitrary transforms. So on metafile playback, you'll be able to specify one of these transforms, and it will be, you can play your little metafile pictures sideways or rotated or sheared. You can also specify clipping. This will reduce some of the usability problems we've had with metafiles. Allowing this new transform to be specified at that time. And of course, the metafile transform itself is not metafileable. Kind of a funny issue. You have to worry about that. But whatever. Okay. Also, for consistency with the new transforms, we have a rotating bit blend. That is, if you say that you want to blend some image from here to there, and you have a rotating transform, well, the image gets rotated properly. Half toning, color blending. We're adding this to our stretch flit and rotate flit functions. The mix modes that they've had when pels needed to get combined or spread across other pels have been pretty primitive. Windows was originally designed for black and white devices, so it had and, or, ignore, that kind of color combining capability. Great for single bits, but not very good for color. So we'll be adding half toning and color blending algorithms. We'll be adding correlations. That's hit testing. You set a particular rectangle, and then you play your graphics functions through it, and we'll say whether or not any pels are actually turned on in that particular rectangle. So you can see if your mouse is pointing at some object or something. So we'll be adding device-independent color. The particular kind of model we're talking about is what we call calibrated RGB. That is, will allow the device, or will allow the applications to specify what kind of XYZ or tri-stimulus space they want to be in, and we'll do arbitrary linear transforms off of that space. So we'll say this device works in this orientation and has these limits, the gamut, and then the application can read that back or set the way it wants to talk about colors, and GDI will do all the translation in between. We'll still keep open the old channel, which is some RGB thing, which was really very device specific, so that old apps who use that get what they want, and of course it's also very fast. You don't have to do 3x3 transforms. Okay. In addition, we'll be adding CMYK colors that apps can set. Some people have said that would be useful. Scott already mentioned Unicode support. All of our APIs that take text strings will be duplicated. We'll add a whole new set, and they will take Unicode strings. So the application will have a choice. Printer control APIs, these used to be in, well, for the most part, these used to be in escape functions. We're just making them all clean APIs. And in addition, we're adding capabilities to change modes inside of documents. So if you're printing some long documents and you have a spreadsheet in the middle, you might want to go to landscape mode for a while, and then back to portrait mode. Okay, and finally, scalable fonts. These are also being added to Windows 3.1. This is TrueType for the most part, and we'll again have these features. So that's it for new features and stuff. But I'm willing to answer any questions you have about how the graphics works or what we do.
One of the earlier questions was about performance.
Yes, about performance of the client server? Yeah, that we expect to be in the 5% range. Okay, so 5% degradation from if we didn't do the client server split at all. Okay.
What abstractions do you use? What calls do you make for the graphic devices?
What calls do we make? We make very few. There's a bitlet, and then we allow the device to take over all the generalized levels of bitlet. That is, you can do a stretch lit, rotate lit, half-toning, blending, if desired. Okay, but only the fundamental bitlet is required, and if they don't do these more advanced ones, that's fine. We also hand down a bunch of path calls, which are really stroking and filling calls. We'll allow a device to do arbitrary geometric wide line stroking of paths, okay, or filling of arbitrary paths. But again, we'll take over the simulation of these things in GDI if the device can't do it. What we require of the device driver is being able to draw simple lines. Okay, and we'll construct things up from that. The next primitive, however, is filling of trapezoids. So something top and bottom are flat and two arbitrary vertical type edges.
What's required? Trapezoid fill?
Well, it's not exactly required. It's recommended. Rectangle filling is required. So if someone gives us a circle primitive and the device can't do path fills, then we'll send him down a clipping region that's supposed to be filled, but then the device actually calls back and asks, well, what's in this clipping region? We prefer that the device ask in terms of trapezoids, enumerate trapezoids that make up a circle, because that's fairly efficient. But if the device is, well, not that smart, then we say, fine, we'll give you rectangles. And then finally, text output is required. So, and that consists of, well, very many different things. The application, or the device driver can ask for outlines that it will fill, or typically it will ask for little bitmap images and where to put them. So, pretty simple stuff.
What about the colors? Changing color map?
Changing color maps. Yes, well, some device drivers will be able to export a palette change function. and if they do, then we'll take advantage of it. We will call and say, set your hardware palette to have this representation. Okay. If they can't do it, then of course we just ask, what is your representation? You know, what colors do you have? And then we will take care of most of the color translation before it gets to the device, except for things like bitlets. If you have a bitlet, then we'll say, here is the source bitmap. We want you to put this on your device, and here is a method you can use to translate. And then you can talk to this method, and you can say, well, are you so complicated that I can't just get a simple array? You know, but if you can get a simple array, then you just have a little translate table, and you play as fast as you can through the translate table. You might also find out the array is trivial. Okay, otherwise you end up with a callback function where you have to take each pell that comes in, send it up, and we'll translate it and send it back to you. So it has a whole range of complexity. Okay. All right.